Hello. Thank you for joining me today at John Galt Solutions. My name is Barry Keating. I'm Professor of Finance at the University of Notre Dame, as well as one of the co-authors of the book, Business Forecasting with ForecastX. In this segment, I'll be discussing how to run a simple exponential smoothing model using the ForecastX wizard. On the screen before you, you see the equation that we use to calculate a simple exponential smoothing model. The forecast in time period t plus 1 is a function of the actual value of whatever we're forecasting in time period t and the forecasted value in time period t. And the two are related to one another with something called an alpha factor or smoothing factor. It's a number between 0 and 1. It doesn't equal 0 or 1, but it will be between 0 and 1. What the ForecastX wizard is going to do is to figure out the optimal smoothing constant in order to minimize mean absolute percentage error. To demonstrate this, we're going to use the index of consumer sentiment as the time series that we want to forecast. With simple exponential smoothing, it is usually the case that we're forecasting a value of a set of data that is a level set of data. It's stationary, it has no trend, and it has no seasonality. To begin, I'm going to put the cursor in the upper left-hand corner, and I'm going to call the ForecastX wizard box. You'll notice that the ForecastX wizard has correctly picked out the periodicity of this data as monthly, and it's correctly filled in the fact that there is one set of labels in the first row of our data. I'm going to leave the number of forecast periods at 12, and the method that I'm going to select is simple exponential smoothing from the drop-down menu. There is an opportunity to put in the smoothing constant. You don't want to do that. In fact, you might want to unclick the Edit Parameters box the way that you see it on the screen right now. In this way, when you ask for the forecast, the ForecastX wizard is actually going to pick out the optimal smoothing constant. I've already selected the statistics that I want to take a look at and the particular kind of report that I would want, in this case an audit trail, so I'm going to hit Finish. On the screen before you, you see the blue values are the actual values that we had in the original time series data set for the index of consumer sentiment. The green values, on the other hand, are actually the fitted values in the historic period, all the way out until we get to the end of the historic period where you see the red forecast leading out into the distance. If we page down, we can see the ForecastX wizard actually shows us the original data, the fitted data, which are the forecasts inside the historic period, the difference between the original data and the fitted data, those are the errors in each period. And if we page down a bit further, we can see the accuracy statistics. In this case, the mean absolute percentage error turns out to be a relatively small 2.95%. Another measure of fit is the root mean square error, 3.61. That's in the units of the thing that we happen to be forecasting, the index of consumer sentiment, which is centered around 100. Above 100 when the economy is doing quite well, below 100 when the economy is not doing quite so well. Under the method statistics, you can see you have a list of exactly what you've asked for. We've asked for a simple exponential smoothing model, and it turns out that the alpha factor, or the level smoothing constant that the ForecastX wizard gave us, the optimal smoothing constant, in this case was 0.80. And that's how to run a simple exponential smoothing model.